Hello, welcome to the video on similar right triangles. This is our first example set A. And as usual, I hope you had a chance to watch the lesson. I think it's really critical that you have watched the lesson first before you actually start these problems. Because I stressed in the lesson that you really need to have mastered in previous lessons this idea of how to work with similar figures, specifically similar triangles, and solve those type of problems using ratios and proportions. Then, of course, that would lead to your ability to solve proportion problems, etc. So you should be very, astute at those skills. If you're a little shaky on those things, like I was focusing in on the lesson, you want to go back and review because really those are going to be the fundamental core skills that we're going to be using in these problems. But what we learned in the lesson was a very interesting and practical theorem, I think, and that was the following. Okay, so if you have a right triangle, as we do here, okay, if I have a right triangle and I draw the altitude to the hypotenuse of a right triangle, well, what's been created are three triangles. Okay, so we have this small triangle, we have this medium-sized triangle, then we have the overall large triangle, and all three of those triangles are similar. Okay, so if you know that you have three similar triangles, then you can set up all kinds of different proportions to solve for unknowns, and that's what we're going to do here to solve for x. All right, so that's the general idea behind this whole topic. Now, anytime you're setting up a proportion, okay, you want to make sure that you're involving the variable that you're looking for. In this case, it's going to be x, and the given information that you have, and that would be 4 and 5. So here's how I'm going to set up my proportion. And you'll see in other problems, there's a number of different approaches that you can use and various proportions that you can set up to solve for the variable. So if you did it a different way, as long as you're getting the right answer, that's what matters. So what I'm going to do is I'm going to compare x and 4, and x and 4, I'm focusing in on the small triangle now. Okay, so notice that x is the longer leg of that small triangle, and 4 is the shorter leg of that small triangle. So I'm going to go x over 4. Okay, so that's a comparison of the long leg over the short leg. Okay, so now I'm going to select another triangle. I have 3 now to work with, right? 3 similar triangles. So I'm going to set up another ratio to form a proportion that is going to compare the long leg over the short leg. Okay, so I'm going to use this triangle right here, right? Where 5 is going to be the long leg, and now x is going to be my short leg. Okay, so you see that? So here I'm using my medium-sized triangle. So I'm going to have 5, that's my longer leg, over the short leg, which is x. Okay, so I'm involving that variable that I'm looking for and the given information. So that's a kind of, I think, it's probably the most critical skill when you're working these problems is your ability to set up these proportions correctly. Because if you can set up these proportions correctly, solving them should be pretty straightforward. Involves a little bit of algebra, okay, which I know is one of your favorite topics. So it should be a piece of cake, right? So let's go ahead and solve this proportion right here. Okay, x over 4 equals 5 over x. So if you haven't tried to solve that, you might want to go ahead and do that now. All right, so we're going to go ahead and use the cross product. Okay, so it's going to be x times x is x squared equals 4 times 5, which is 20. So to solve for x, I'm going to take the square root of both sides. So x would equal to the square root of 20. Now, if you left your answer this way, some math teachers, and even myself, might dock you a point, maybe it's like -1, because you really want to always simplify radicals. Okay, this would be kind of like similar to, or in comparison to leaving your answer like this: x equals, I don't know, say 10 over 30. Okay, so would you leave your final answer like that? 10 over 30? No, really, your teacher wants you to reduce the answer to like 1/3, right? So if you don't simplify fully, teachers don't like that, and for good reason, okay? Because it shows that you may not, understand how to reduce or simplify. And this is kind of a common trait with a lot of students dealing with radicals. So make sure you fully simplify radical expressions. Okay, so the square root of 20 is equal to the square root of 4 times the square root of 5. Okay, so I'm just separating the factors here of 20 because I have a perfect square right there. So x would be equal to the square root of 4, which is 2 times the square root of 5. Okay, so that's the answer I'm looking for. Now, if you went ahead and used your calculator and actually got a decimal for the square root of 20, that's, it's not part of the directions stating, not to use a calculator, but really just make sure you can simplify these radicals, because if you didn't, this would be the answer I would be looking for as a math teacher. Okay, 2 times the square root of 5. All right, so hopefully this makes sense. And if this makes sense, if you understand how to set these proportions, you understand the theorem, then the rest of these problems should just kind of, make sense to you. So let's get into the second one, a little bit more interesting. So I'm solving for x. Okay, so x is this segment right here. So I'm solving for x, so I'm going to set up a proportion that is going to involve my given information. So that's 6, 3, and x. So what I'm looking at here, I'm focusing in on this small triangle first. Now, before going any further, remember there's a number of different ways, or a number of different proportions you can set up to get to your answer. Okay, but this is the one I did. So I'm looking at the small triangle, and I see I have this side and I have this side. And that would be the hypotenuse over the small side. Okay, so this is the hypotenuse, and this is the small leg or side of that right triangle. Okay, once again, I'm looking at the smallest triangle here. So now I want to go ahead and find or build another ratio that involves the hypotenuse, okay, and the small side of another right triangle here, okay, because I remember I have 3 to choose from. But when I do this, I got to really be careful which one I select, because I need to involve the variable I'm looking for. So I got to involve this x here, okay? So what I'm going to do is I'm going to say this length right here is the hypotenuse of the largest triangle, and now 6 is the base or the shortest side of the largest triangle, okay? So the hypotenuse, this entire length here, would be 3 plus x. Okay, so I got 3 here, I have x there, so this would be 3 plus x. Okay, that's my hypotenuse, and my shortest side of the largest triangle is 6. All right, so I'm going to put a 6 here. Okay, so once again, if you're able to set up this proportion, I personally think you're like 75% there. And as a math teacher, I would give you a lot of credit. I'd probably give you at least half credit if you're able to show me that you understand enough to set up these proportions. So now you're going to use your excellent algebra skills, and we're going to use the cross product to solve this proportion. Okay, so this is going to be 6 times 6, which is 36, equals 3. And now anytime you have a plus or minus with a variable, this is an entire quantity. So this is going to be 3 times 3 plus x. Okay, so if you're a little bit confused there, remember, anytime you have a plus or minus with a variable and a number, that's a quantity. So you really have to think parentheses or grouping symbols around that particular quantity. So we have 36 equals 9 plus 3x. So I can subtract 9 from both sides. I get 27 equals 3x, and x would be equal to 9. Okay, so once again, I didn't look at this problem in another way, but there could be another approach, another proportion you could set up to solve for x. But the idea here is when you're setting these proportions up, you want to use the given information you have, okay, the values, like in this case it was 6 and 3, and the variable you're looking to solve for, x. Okay, so this is really key, your ability to set these proportions up. All right, so hopefully this is making sense, and if you're struggling a bit, once again, on proportions, solving proportions, go back and do what you have to do to brush up on those skills, and I promise you this will all come together, but you have to work at it. Okay, all right, so we'll see you soon. Keep working hard and good luck.